Okay, you on YouTube?
What?
YouTube. Did you get the link?
Yes.
Okay, can you see now? Working?
Yes, I can see the YouTube.
Okay. I wanted to start with logic and see if you already know stuff. So, you know what that makes?
T and F. TF?
No, okay. T is true and F is false.
Uh, hmm. Okay. If it's like an AND gate or something,
Yes.
then this would be false, because I'm thinking of it like two inputs.
Uh-huh. Okay, do you know what this equals?
True.
Okay, what about
Okay, that's gonna be a no.
no?
I think false.
Okay. And then
I
there's
think it
one
can
more.
like
This one might be easy.
I think this is gonna be a false.
Yeah, so do you see how these two are similar?
Uh, okay, they like swapped the position.
Yeah, the order doesn't matter for and.
Hmm. Are there some gates where order does matter?
Yeah.
Hmm.
Like implies.
I'm not sure what implies is. I don't know what
That's
implies
okay.
is.
Okay, so there's other ways to write these things. So you figure out what that means?
1 and 0. I don't know what that means. Is the and supposed to be a gate?
Yeah, and is a different way to write and. What do you think one might be? Or maybe
Uh,
zero is easier.
like off, not existing, no pressure in like the water pipe, to use kind of a Feynman example. He like described gates with like you could imagine water. Uh, it's like, is there like water pressure in this pipe, or is there not water pressure in the pipe?
Sure. Okay, so yeah, one is true, zero is false. Make sense?
Yeah, and the
It
and
can also be
requires
on, off,
two.
yes, no, whatever. Yeah, this is
And
and.
okay, and requires two ones, yes inputs. It needs two like active trues do thing.
Yeah,
So this
and
is
is,
gonna be
you said one?
yeah, one.
Okay, I didn't hear you well. And is like plus, where you could actually do it with multiple things.
Huh. Not used to that. I think we did something with grammar with that though.
Mm-hmm. Okay, so you could have like and then, oops, tab. All right, one, 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 zero, one. All right, do you know what that makes?
I think that's gonna be a zero.
Yep, you got it.
Okay, so and requires all inputs to be true.
Yeah. Yeah, so the and that only works with two things is common, just like with plus. It usually deals with two things. But you can have a version that just takes a bunch of things.
Okay. I'm not sure what the difference between and not and is. They seem like kind of the same thing, just flipped outputs and inputs.
That is not, you don't swap the outputs with the inputs.
Wait. So with not and, I think it's like if there's any true inputs, then it's a false, and if there is,
That's
and if
incorrect.
oh, okay, then I don't understand not and.
That's okay. Let's try or let's try not first. Okay, so not t equals.
Hmm. Okay, I'm not sure. What do I think's gonna happen? False.
Yeah. What about this one? You probably haven't seen this symbol. This means not.
Okay, so exclamation mark is not. Okay, so not false. I feel like it's gonna be true.
Yeah. So not just flips it, switches it to the opposite.
Hmm. Okay, so you have like your inputs, and that's like, okay, let's not have those inputs as the output. Is something. Not sure. So could he have as many inputs as he wanted in not? How would that work if you had like two inputs?
No. Not just deals with one input, one output.
Hmm.
I mean, you could make something that had multiple inputs and multiple outputs and flipped all of them, I guess. Yeah, the people actually, you can do it with bit strings. So if you had like 1100 and we wanted to do not of that, then we could have it equal 0011, like flip everything.
Hmm.
You could have an operation that did that.
Okay, so if you had like good flip thing. Yeah, that seems interesting. Okay.
So you can do the same thing with like and. You can do like 1100 and 1010 equals.
Zero.
No, the output is going to be four different things. So what this means is take the first ones and them together, and then take the second ones and them together. It's
Okay.
just doing four different ands at once. So the first answer uses the first digits. What do we get?
Okay. That's gonna be a one.
Yeah, and then what's the next one?
It's gonna be a zero, and then a zero, and looks like a zero.
Yeah.
Huh.
This isn't
Okay.
too important. It comes up in programming sometimes.
Huh. So you can like have a gate which like okay, so you have like a input string or whatever where you have like two numbers of the same length, and then you like look at the one of the digits of them or like two digits of both of them. Then you do like a logic operation on those, and then you like make a output number for that, and then you look at the next digit and for the next two digits, then you make a new output number, and the
Yeah.
next two digits, and a new output number. Huh.
Okay, so the next one is or. So like T or F equals.
Okay, I feel like or is like either of them need to be true. So I think this is going to be true.
You're correct. Okay, and then one. This is a symbol for or.
Okay. I think this is going to be true.
Yep. Okay, and then 0 or the double one is also a symbol for or.
And this is going to be. Why are there two ors?
Um, Programming languages commonly do this because they use the single one for something else. It's actually two different versions of OR. But yeah, anyways. You know, if you've already used up one line, you can use 2 lines.
Hmm. That feels kind of like a ghetto solution. I'm not sure though.
I mean, it's a little bit ghetto. It works okay.
False.
Yeah. Okay, yeah, so that's the thing with and as well. So you can have like this.
So we already used and for something else. We need a new and.
Hmm.
This
What is,
one's the
what's this one equal?
true.
Yeah.
1. Okay, it's like, where's and? 7.
Yeah, there's one more common one. It's not as well known. So
Common one. Oh boy.
yeah, this one's like reasonably standard.
Okay. I feel like the X is gonna be a not. Does X mean not?
Incorrect. The X
Oh,
means exclusive.
exclusive or. So it has to be specifically, or maybe you can't have 2 inputs. Like if it's 2 trues, then I think it's maybe gonna be a false. That's what I'm
Yep, you
feeling
figured it out.
with the XOR. Okay.
So what's this one?
So this is just a normal or. So this is gonna be a true. Because one or the other is true. Okay. T is going to be false. F is going to be false. FT is going to be true.
Yep, you got it.
Wow,
So in standard English, the word or is ambiguous between or and XOR. Sometimes people mean one and sometimes they mean the other. Sometimes they mean
is this
like if they say you can have cookies or cake, they usually mean you can have one or the other. You can't have both though.
it's like and or is more specific.
Yeah, and or means inclusive. When you say cookies and or cake, then you clearly can pick either one or both.
And if you say like cookies and cake, like maybe you have to take both.
Mm-hmm. Yeah.
Okay.
But in logic, then we always use or to be inclusive
Hmm.
instead of exclusive.
Okay.
It's just a convention. You know, we have Zor. That's the one we made be different.
Okay. Wait, so this. Oh no, I did overwrite. This one is the or. Is there a symbol for exclusive or?
There are a variety of symbols. The best place to find these symbols is Wikipedia.
Huh.
Wiki logic. Logic wrapper? That came up first. Is this the right page? Not the right page. Wiki logic symbols? Maybe that's the one. List of logic symbols. Here we go. Right, okay, here are symbols for not. Yeah, the tilde, and this thing that's sort of like a tilde, and the exclamation mark.
Huh. Not used to it being pronounced tilde.
Oh, am I pronouncing it wrong? I don't know.
I've heard it as tilde, and that's the only way I've heard it.
Yeah, it might be that.
Huh.
Okay, and
Logical.
then here's and or, not, and, or, Zor.
Wait,
See, it's got all 4 of them in a row because they're common.
wait. Logical conjunction? What does that mean compared to and? Is that like the same thing? I'm kind of confused.
Yeah, it's the same thing.
Huh. So it's like the technical word for it or something.
Yeah, conjunction means and, it means joining. Disjunction means or. They have inclusive disjunction and exclusive disjunction, or just or and
Yeah.
XOR.
I remember you mentioning that, uh, okay, blog post recently, someone used the word disjunction, and I was like, I don't know what that means. And then you like made a comment and mentioned
Yeah,
that it means
they were
or.
just using fancy words to fuck with me.
Huh.
They thought maybe I wouldn't know them or something. Like their main point seemed to be I accuse you of not knowing math and probably shouldn't have written the thing you wrote if you don't know math.
Huh.
However, they were incorrect.
Disjunction.
Okay,
Logic.
so here's a Ruby prompt, and I can type in mathy things.
Man. Wow.
And the Ruby symbol for XOR is the exponent symbol.
Ruby symbol for not or the
Yeah, if you want to do an
exponent.
exponent in Ruby, you can do
Oh
like
no.
2 to the 5th, and you get 32. They use double multiplication symbol for exponents.
Okay, so or is the exponent symbol.
XOR.
Oh. Exclusive or is the exponent symbol. Very scary.
So yeah, you can use that equals, what's this one equal?
Okay, so this is going to be an or, and one of them is true. That's going to be a true.
Yeah, exclusive OR means one or the other is true. Okay, so this is the basic logic stuff,
Okay,
and you can relate it to English sentences. So or we can look at NAND, NOR, and implies later.
oh,
Um,
hey, the examples thing look confusing and hard to understand on the Wikipedia.
here,
I'm bad at reading math things that Wikipedia uses. Sometimes there's like formulas or whatever, and they look weird and not normal, and I don't know how to read them.
I don't think you need to worry about these.
Hmm.
They're not that hard though,
Okay.
but you don't want to deal with those up there.
Tautology?
And here they're saying not A equals A. Right, so you can chain knots together, like you have not 1 equals, what's that?
Okay, so it has to be not a not. Okay, what does not do? It kind of makes it go from 1 to 0. Okay, so we're at a 0, but then we put a not on it again, so it goes from 0 to 1. I think it's 1.
Yep, you can just do the knots one at a time. So if you have 3 knots on a 0, what does that do?
Okay, so we get a 0, we get a 1, then we get a 0, then we get a 1. Wait, this
Yep,
feels wrong.
why?
Because I felt like we had the same starting input, and that, like the first one, we did it twice and we got 1. So if we do a third one, it should be 0. But then I realized we have different starting inputs.
Oh, yeah. Yeah, if you're not sure, you can go step by step. So you can just do 1 knot at a time, so you got not, and then what would this one be?
Uh, okay, so wait, I'm not
So we're
sure.
just doing one
Is
of the knots, and we're leaving 2 for later.
okay, we're just doing one of the knots. So we're gonna get 1.
Yeah, and then if we do 1 more of the knots, we'll have 1 left over, and what do we got?
We're gonna have 0.
And what's that equal?
1 more knot, so we're gonna have 1.
Yeah, so does that make sense? How you can do it step by step?
Yeah, so it's kind of like you have a NOT gate, then you put another NOT gate on top of it, which is attached to it, and then you have another NOT gate on top of it, which is attached to the previous NOT gate.
Yes. Okay. So
Is there like a combiner thing? Like, what if you have a gate with, what if you have like two outputs and you want to combine them? Oh
combine them
wait,
how?
uh, I don't know. I guess just combine them so that if any of them are true, it outputs a true. And you could use an OR gate for that, an inclusive
Yes.
OR.
Yeah. So or and are different combiner gates. They combine two things into one thing in different ways.
Huh, so you can use gates to combine things.
Yes.
Okay.
Okay. So the stuff is all related to English. So uh can you see how it relates to this sentence?
Uh, okay, he has one input and he has second input. So both inputs are true.
Well, that's what I'm claiming. Yeah. So what state of affairs has to be the case? What fruits do I have to have for this to be true?
Okay. You need an orange and you need an apple for the sentence to be true.
Right. So if I have only one of them, is it false?
It would be false if you only have one of them.
Okay. And what about now? What if I only have an orange?
All right, and then you could get into the problems with like the inclusive or exclusive. So if you have an orange, it's fine. If you have an orange and an apple, it's fine. If you only have an apple, it's fine. If you have neither, then that's going to be a false.
Then I'm a liar.
Yeah.
Yeah. So usually you can assume it's inclusive or, but it does depend on context sometimes. But if people are trying to talk about like logic stuff, then usually inclusive or.
So if you want to be true more percent of the time, you should just replace every and with an or.
I mean, sure. Depends though. Like you could say if I have an orange and an apple, then I have at least two fruits. Okay, what do you think of this statement?
Okay. Assuming both of those are fruits. Uh,
Oranges and
and
apples are fruits. You know that.
no,
You don't know that? Okay.
not really familiar with fruits and vegetables. There's also like some controversies with what a fruit or vegetable
Oh,
is.
yeah. I
I
mean,
really just like,
I wouldn't worry about the controversy. It's just like standard things. People call them fruits.
wait, so is fruit like generally it's grown off of another plant kind of?
Uh, sort of, not exactly. Don't worry about it.
Okay, then I have at least two fruits. Yeah, I guess that would be true. You could also say you have at least zero fruits.
That would also be correct, yes. However, all right, now I say this. What do you think?
Then, uh, no, because you could have one fruit as well.
Correct. So, he said that you could just replace all your ands with ors, and then you'd be right a lot more. But you have to be careful.
Okay, change all of your at least to negative infinite.
At least
Would
negative
that work?
infinity. Hmm. No. Okay, like, watch this. I have a number which is at least negative infinity. It's bigger than 5. What do you think?
Yeah. So at the minimum, it's negative infinity. I feel like this doesn't exclude a maximum of 6.
It could be 6. Okay, so
Oh wait, it is. It
if
is.
I have a number which is at least negative infinity, then how about this? I'll make it clear.
Then I I guess you need to add then it might be.
Then it might be bigger than 5. Okay, so, but if we use at least 42 instead of negative infinity, then our sentence comes out, what do you think? Is it truer than before?
Okay. If I have a number which is at least 42. Okay, this seems true. I'm not sure what you meant by truer.
It's truer than this one.
That's true.
Because true is more true than false is.
Hmm. I think that's more true than false.
Okay, so then people try to make arguments. They're like, if minimum wage helps poor people and minimum wage has no negative side effects, then minimum wage is a great idea.
Hmm. Okay, that seems like it would make sense, yeah.
Yeah,
I agree with this.
right. And then they try out this one. There we go. What do you think of this one?
Okay. If minimum wage, then minimum. Oh, yeah, that one, not the same.
Not so good anymore, huh?
When you add the no negative side effects, it kind of makes your idea OP.
I know, right? The thing about when you add that, though, is then people will say, well, okay, let's consider if there are negative side effects or not. So that's why they write the other one, because they don't want to talk about the negative side effects.
Like, I think you could help poor people in some way and then hurt them in another way. Like, you could uh, help them out of a car by kicking them. So, like, you help them get out of the car, but now they're injured from a kick.
What do you think about this one?
Wait, uh, no.
Why not?
Because it might have no effect at all, and then you just, like, added a law, which, wait. Okay, I'm
Okay,
thinking of
that's
it
true.
like
Let's try
you're
another one.
adding a law, and then, like, it's just a waste of paper, but that's a negative side effect.
Okay, what about this one?
Okay, if minimum wage has no negative side effect, then minimum wage is a great idea, or an okay, non-harmful idea. Mm-hmm. Okay, so I feel like great idea is harder to show, so we can try to look at if it's an okay, non-harmful idea.
I was just
Okay,
trying to cover the case you said where it doesn't really do much. So I'm like, then it's great or doesn't do much. Now, do you agree or not? Or is there any
okay.
other problem?
If minimum wage has no negative side effects, then it's an okay, harmful. It seems like, I'm not sure. It seems like it's kind of just because this could include it doing nothing, and that seems bad.
I
But
was gonna count nothing as being okay. Like,
uh,
I'll even add that, including doing nothing. Or of more cases. I was just like around 0 or better.
uh, huh. I'm not sure what I think about non-ideas, but I'm just gonna go ahead and agree with it.
Okay, there's a problem with this one. Minimum wage can have negative direct effects.
Oh, huh. So
Problem isn't
shooting,
always side effects. Sometimes it's the main idea.
so like shooting someone in the head to kill them, uh, like if you don't look at the direct effects, then maybe it's not too bad.
Uh-huh, yeah. Okay, so that's the very basics of logic. It seems like you've done some of this before because you knew like most of the true and false answers already.
There was one video game I played where it had some logic gate stuffs, and so I learned a bit about AND gates. Didn't really use any of the other gates though. AND gates are useful.
Yep. Okay. So you wanted to know about NAND, so we can do these other three.
Okay, not or. Wait, so did you just
So,
like take the output of OR, then put it into a NOT gate or something?
yes.
Wait, so do you take the output of and put it into a NOT gate?
Yep.
Whoa.
So,
So it's like not and, not or. Are they just kind of ways to turn like go from two gates to one gate for more convenience or something?
yeah, so the reason NAND is particularly important is that they're easy to build physically. So you actually build them as a single gate and it's easy to make.
Hmm.
And it also turns out that it's very powerful and useful.
Yeah, you said
So,
something about universal computer NAND gate. I don't really understand that.
yeah, so if you just do NANDs, you can create NOT, NOR, OR, and. You can create the other gates just from a series of multiple NAND gates.
Hmm. Okay, so is there like a specific amount of NAND gates that you need, and then it's a universal computer or something? Or could you need like infinite potentially? That's like I think what one person kind of said who you were discussing with. They're like, well, a NAND gate isn't a universal computer because you might need more or something. And I'm like, do you potentially need like infinitely more NAND gates? I'm not sure.
No, because you can have a computer design that reuses gates more than.
Hmm.
So, like, my Mac has a certain number of gates in the CPU of whatever types. It doesn't have an infinite number, it just has a bunch.
Hmm.
And then if I want to do something and there aren't enough gates, I just have to do more than one step. I use some gates and then use some more gates like a little while later, and then wait a little and use some more gates, You just can't do everything at the same time. Okay, so what is this one? True and NAND false.
Okay, not. So let's look at the NAND operation first. I mean the AND. Okay, so we have a true and a false. And is gonna call that a false. Okay, then we're gonna not that, so we're gonna go into a true.
Oh, you weren't done. Okay, you said true. Okay, next one.
Okay, the AND operation says true, but the not operation gives us false. So false.
Okay.
This is gonna be a false and then a true. I'm reading like the AND operation, then the not operation. This is gonna
hmm
be a false, then a true. So true.
Okay, and then NOR.
Okay, so we look at the OR operation. So uh, at least one of them has to be true. If that's a truth, then a false. Okay, it's true. False. Uh, it's true. Okay. Hmm. False.
Uh-huh. So intuitively, NAND means not all of them, and NOR means not none of them, like some of them. Make sense?
Okay, nor is not nothing. Wait. What's nor? Okay, so the true one is
Oh, no, I think I said it wrong. You figure it out. What's NOR? Or what's NAND? Start with
okay.
NAND.
What is not?
Intuitively, short explanation. What
Okay.
makes it come out true?
What makes NAND come out as true? Uh, okay. So okay, true. Uh, if anything is false, NAND is true.
Yeah, so
So
like not everything.
yeah, so like not everything. It's like everything is how and is true. So it needs to be not everything.
Yep. Okay, and then NOR.
Mhm. Not or. Or is like at least one of them. So not or would be okay, so it'd be the opposite of not at least one. So I think that would mean anything but one.
Anything but one? What about this
I'm
one?
not sure. What's this? This is one. Hmm. Okay, so what is or? Needs something, anything, or needs like anything, and then it's true. So not or would need not anything. So is that right? Not anything.
Yeah, do you
Okay.
know another way to say not anything?
Hmm. Nothing?
Yep.
Huh.
Okay, and then we have one more, implies. This one comes up in English. So you can try to figure out how it works.
Is something Socrates beard man mortal?
Um, that is a more complicated one.
Huh.
Well, it's similar. Okay, so the Socrates stuff, they're using two things and they're saying two things imply the conclusion. If you have both premises, you get the conclusion.
It's like
But
X and Y then Z.
yeah, X and Y implies Z. Also use then. If X and Y, then Z. But you can do implies with one thing.
If true is true, that implies true is true.
Uh-huh, kind of.
It also
So
just like directly says. If something directly says, that might also imply what it is directly saying. I'm not sure though.
okay, what do you think about this one?
Hmm. I'm not sure if it implies he's human, because I'm not sure what implies is. It seems like it's just directly saying he's human, but that might also include implying.
Uh, do you understand this if it was just an English sentence and you weren't thinking about logic?
Uh, I don't know. Being living here.
So
The dictionary thing said not directly stated.
Yeah, that's a common usage. Imply can mean hinted at.
Oh,
But it can also mean logical consequence.
there's a lot. Okay, in fact, I'm trying to suggest something. Huh. Suggest as a logical consequence. So if Joe is human, that would imply like Joe's human.
Yes. Okay, so Joe is human. Is the claim true? Okay, so suppose Joe is a living human. Is the claim true?
Okay. Yes.
Okay. Suppose Joe is an undead bear. Is the claim true?
It's gonna be a no.
Do you think this is false if Joe's an undead bear?
The thing you said is this would be false if Joe's an undead bear.
Okay, let me try writing it a different way.
Wait,
Why do I have true in front of it? Okay. So
wait, I might be
if
wrong.
if
Joe being human.
Joe is a living human, then Joe is a human. Okay, do you think this is correct?
Yeah, even if Joe's an undead bear, because it's assuming if he is a human. It's like,
Yeah.
okay, turns out Joe wasn't a human. This is still true because I was using an if statement. Like the if was incorrect, which means like I already knew this other part would be incorrect.
Okay, so implies deals with a conditional. If the first input is true, if the if part is true, then the second part has to be true. The then part has to be true.
Hmm. Okay.
So, yeah. So let's do a different example. Maybe this is a better one. Okay. Joe being good at math implies Joe will pass the test.
Mm.
What if Joe... Okay, so Joe is good at math. Joe passes the test. Conclusion. Claim. Okay, so like... Does this make sense? Claim. If,
Okay.
Joe being good at math implies he'll pass the test.
Yeah.
And now we're going to tell you what happened. Suppose Joe's good at math and Joe passes the test. Conclusion about the claim.
I don't know. Okay, so what is implies? Okay, function. Okay, at first I'm feeling like this could be false because maybe he gets bored of the test and then does something which counts as cheating because he's like doing extra work because he thinks it's too easy. And
It
then he,
says right here, Joe passes the test.
uh, okay. And
No cheating, just passing.
hmm. I don't know what the conclusion would be.
Was the claim correct or incorrect?
Uh, okay. I don't know. I feel like the claim could be wrong, and then he like passes for another reason.
Yeah, you're right. So maybe he got lucky or something. But suppose this was a guarantee.
Okay, so like if you're good at math, it's like guarantee that you pass the test.
Yeah. Suppose that this is the guaranteed result.
That's okay. Joe.
Then can we agree with the claim or do we disagree with it?
Guarantee. So Joe being good at math guarantees he passes the math test?
Guaranteed result is he's good at math and he passes the test.
Guaranteed. Okay, the guaranteed result is that he is good at math and that he does pass the test. Okay, and the claim was that him being good at math implies he will pass the test. Okay, I feel like I might be slightly stuck, but I'm still feeling like no on the claim. Because it's just saying that it implies he'll pass the test.
How about this? Let's try it a different way. Does this contradict the claim?
Mhm.
We can get rid of this then.
This does not contradict the claim.
Okay, so no. So is it compatible with the claim being true?
Yes, it is
Okay.
definitely
So if
compatible.
you're basing it only on this information, would you think the claim true or false?
Okay, uh, I don't know. I'd kind of have it like undecided. Like, I don't know.
Right, but like if you had to guess,
If I
it
had to
fits the
guess.
claim, right? It doesn't contradict the claim. It fits with the claim. The claim could be true.
Okay, fits with the claim. The claim could be true. Yeah, it could be true.
Okay. Now, Joe is good at math and fails the test. What about this one? Does it contradict the claim?
Yes, it would contradict the
Okay,
claim.
so does it agree with the claim? I'm gonna ask it this way, okay?
Okay.
So the first one agrees with the claim.
Uh,
Do you agree?
yeah.
Okay. Now this one does this one contradict the claim?
Okay. So is good at math, and Joe fails the test. And the claim is Joe being good at math implies Joe will pass the test. Uh, huh. I feel like implies is a kind of not very like uh absolute word. I think and or are like very absolute, or like just absolute, I guess. But I feel like implies isn't absolute. I don't know if that's true or not. In a logic gate,
Implies is an absolute word in logic. It's not always absolute in English. Because implies can mean like hinted at. Suggested something's true without actually saying it is a meaning of implies, but it's not the one that we're dealing with.
Mhm.
So Joe being good at math implies Joe will pass the test means if Joe is good at math, then Joe will pass the test. Implies means if then.
Mhm. Okay. So if Joe's good at math and then he fails it, then that would uh not agree with the claim, would like contradict the claim.
Okay, yeah. There's other ways you can do it. Implies or means or necessitates or guarantees. These are synonyms
Hmm.
that you could say
Necessitates
instead.
seems
Or
different.
proves or requires or a little more awkward, but
Okay, so implies is just like an if-then statement thing. I
yeah.
don't know what if-then statement means, but maybe. That's about right.
It means if the first part is true, then you're claiming the second part will definitely be true. Guaranteed.
Mhm. It's like if one is a number, then one is definitely a number.
Sure. Okay, so now we just did what if the first part is true, and what if the second part. So here we had first part is true, Joe's good at math. Second part is true, Joe passes the test. And we got yes. Here we have first part is true, Joe is good at math. Second part is false, he failed the test. And then we got a no. Make sense so
Yeah.
far?
Yeah.
Okay, and now we have two more. Joe is bad at math this time. He passes the test. Does that contradict the claim?
No, the claim never said anything about like people. Wait, yeah, it never said anything about people being bad at math. It's just saying
Correct.
like if you're good, then uh you will pass. It never said anything about like if you're Albert Einstein or like if you suck or like if you're dead. Like
Mm-hmm.
it doesn't really know with those. It doesn't deal with those. Like uh not what this claim is designed for.
Okay, and then if Joe is bad at math and he fails the test, does it contradict the claim?
No.
Does it agree with the claim?
Uh I feel like no, but I'm not understanding what this means, and I kind of need to think about it a bit more. So, agree.
Just I'm trying to use agree as the opposite of contradict.
Okay. Uh,
Because contradict is a negative, so it's like more confusing. We want does it fit with the claim?
uh, yes, I think so.
Okay, yeah. So now maybe we could try to do the truth table for the implies operator.
Okay. T implies.
Let's do it in a different order. Let's do this one here. Let's do this one here. False implies false.
Okay, so like if false, then false.
Mm-hmm. What do you think the
Mm,
result of that is?
Uh, then it seems like the implies was true, but I'm not sure.
True. Okay. What about this one? False implies true.
Okay, if false, then true. Uh, Okay, I feel like everything is gonna be true because it's like if this, then that, and it seems like it's always true.
Okay, well, alright, now I have true implies true.
True. Okay, if it's true, then it's true. I think this is also gonna be true.
Okay, and then true implies false.
Okay, if true, then false. Uh,
So if the condition is true, and then the then part turns out to be false, how would we judge the claim?
okay, condition. It's like if good at math is true, like if good at math, then pass test. It's like if good at math, then fail test. Okay, that seems like it's gonna be false, but I felt like everything was gonna be true.
Yeah, this one's supposed to be false. So, point is, if the condition part is false, then it doesn't matter what the result is because you didn't make a claim about it. But if the condition is true, then you're guaranteeing that the claim is true. It's always condition implies conclusion.
Mhm.
And so if the first one's true, the second one has to be true.
The first condition is true. Okay, so then what if the condition is true or false? Okay, I'm having a bit of trouble with like uh, F implies T and F implies F then. It's like
Try
if
reading this. Does this help?
X implies Y means X is true, and I guarantee that Y will be true too. Okay, that makes sense. If
So
X
if
is
X is false, it doesn't matter what Y is. You're fine. And
okay,
if they're
so
both true, you're fine. But if X is true and Y is false, then you broke your guarantee.
okay. It's like if X is false and I wasn't making a claim about that, whatever. I'm saying that like if it were true.
Yeah, it's like if the shock hire slime, then they'll win the finals. So if they don't hire slime, then I'm never going to be wrong. I don't have to worry.
Hmm. Yeah. The only thinking of it if they like do hire slime, and then if they hire slime and they lose the finals, you will have been wrong.
Yeah.
Wait, what happens if they lose the finals then hire slime?
Well, I meant in order.
Huh. Can it happen out of order?
So, like, when I say if the shock hire slime, I would mean, like, at a particular signing window or something, probably.
Hmm. So you
Like, I
can't just
wouldn't
like
mean if the shock hire slime in 2025, then they'll win the 2020 finals. That would be dumb.
hmm, yes.
So if I say that, what I mean is like Slime is currently a free agent. He'll be hired by someone or not join the league in the next month if the Shock hire him instead of one of the other teams or him not joining the league. Then I'm saying the Shock will win the finals. If he got hired like later, if they traded for him later or whatever, like I'm not trying to make a claim about that.
Hmm.
But yeah, you could ask someone to be more specific. Like you could
But if they
say if
hire
the
them,
Shock hires Slime within the next 30 days, you know? Now we're like a lot safer in the
yeah.
finals in 2020. I don't know if they're even doing like finals though, like because they screwed up the league with COVID and they like have all these mini tournaments now or something, but I haven't watched them.
Huh. This one was supposed to be like one where they go to a bunch of cities as well. Like I think
Yeah,
this
like they're gonna travel.
the COVID rip. Huh. Okay, it's like if true. Okay, one thing I'm not sure about is like if it is false, then it will be true. If it's true and it's true, then
Oh, so like if the Shock do not hire Slime, then they'll lose the finals or something? Win the finals, sure.
yeah.
Okay, so you just take this thing, and what is this? You just evaluate this.
Hmm.
So you find out, like, did they hire slime? Yes. Not that. You just, like, throw a not gate in front of it.
Okay. Did they hire someone? Hmm. Okay, so let's see. They don't hire. Okay. Mm, mm, hmm. Okay, I think I'm confused. Mhm. Okay. Okay, so they do
There's two
hire
different ways to
slime.
do it.
They okay, if they do hire slime, then we're putting a not on that. So like they do hire slime, so this is gonna be a false condition. So like F implies T. And then let's say they do not hire slime, that's gonna be a true condition. T implies T.
So there's two things you can do with not higher slime. You can say not higher slime is a single concept, just this whole group. We're going to take this and we're going to figure out if it's true or not, and then we're going to act just like normal as if there was no not.
Okay.
Like, you can put anything in the X. X could be higher slime, it could be not higher slime, it could be eat a banana. It doesn't matter. It could be not eat a banana, it could be eat 7 bananas. Like, anything that you can evaluate if it's correct or not. So it doesn't matter if there's a not in there or not.
So like we can see, okay, they did not hire slime, which means the condition is true.
Yeah. If the condition is not higher slime, and then that matches the world, then you say, okay, the condition part is true. The other thing you can do is you can say, you can do things like not X implies Y.
Mm. Implies. Okay, so we have like a not gate or something, and then
Yeah, so there's a not gate in front of the X, and then whatever comes out of that is going into the implies.
okay, so we put like X into the not gate, and then we put the not gate into the implies, and then the implies will give us an output.
Yep.
Okay.
So
So we have like X, and then we go into not, then that goes into implies. It's like X could be like, so what is the X going to be? What is the X doing?
okay. So if not X implies Y, then can you evaluate these 4 scenarios?
Okay, so not X implies Y. What does that mean? If we don't have X, not, is it true that we do not? Okay, I'm trying to figure out what not X is. Okay, not X. Okay, so let's put X into a not gate. What is X? It's whether the thing is true. So like moon existing, that could be X. It's like moon existing equals X. Uh, moon exists, X is true. Moon not exist, X false. Okay, so I think that's right. So then, okay, so X. So let's see. Moon exist, X true. Okay, so moon exists, X true. And then we're putting X into a not gate. X, so like X into not gate. Wait, how do you? Okay, I'm not sure how I'd write it to be like we're putting X into a not gate. I guess I'm just gonna do this. Okay, so X is
Do it the other way, not hyphen X.
oh, so
That's way more standard.
hyphen. Okay, moon exists true, which means X is now false. So, hey, wait, so now I'm not sure where I'd put the implies. Well, what does it imply do?
So here's the ones I wrote out.
Okay. Okay. Not X implies what? It's like not hiring
This one's the
slime.
claim, and then if these things are the situation, then how do you evaluate the claim?
Okay, so not X. So we need like a not X, and that will give us Y. So X is true. I don't think we made a claim about X being true. We just made a claim about if X is not true. So X being true doesn't really matter. It like is still in line with our theory or whatever. It still like
Correct.
follows or implies. We're only saying something about X being
Mm-hmm.
false.
Okay, now this one. What should I write on?
Okay, so this one is about it being true, and like we're not dealing with truth, so just like true.
Okay.
Like it follows our claim. Okay,
Now what
so
about this one?
if X is false, then that means Y will happen. Uh, so X is false and Y happened. That follows our claim. That's like what we thought was going to happen, so it's true.
Okay, and this one?
No, did my thing pause? Okay, we said that if X does not happen, then Y will happen. X did not happen and Y did not happen, so that's going to be false. Uh, why is this buffering?
You got it. So in English, if X is false, I guarantee Y will be true. Or another way to write it, if not X is true, I guarantee Y will be true. And that is violated right here. In this case, not X is true, but Y didn't turn out true.
Not X is true. Yeah, so we're saying if not X is true, then Y will be true, but turned out not X is true, and then Y didn't become true if we were wrong. Ooh, if you say we, can it group other people with you so it's like less of a blow? Like if you say I was wrong, it's like, oh, so you like came up with an idea all by yourself and that was wrong? But if you say like we were wrong, then it's like, oh, there are more people. That might make it like less bad if you were wrong. Is that something you can do? Or like that happens socially?
Yeah, kinda.
Uh, so like, into the failing.
Yeah, a lot of times people don't like to take responsibility for things. So they're like, it was a group decision.
Hmm.
And then they can downplay it even more. They can be like, well, the group wanted that. I wasn't sure.
Hmm.
I just went along with it because they seemed really sure. I blame them.
Hmm. So, okay, so that's still like your fault for like following with people without agreeing with it. You weren't like convinced, but you just went with it anyway.
No, I was just being polite. It's not my fault I was polite. That was a good thing. I made the right call.
There's like the common example of like, what would you do if you're in Nazi Germany, World War II? And like, if one of the replies of like one of the SS people was just like, "Oh, I was being polite. I didn't really want to insult Hitler," you know? That would be
If
kind
only
of.
a few more people had been polite, he probably would have felt better and then been nicer to everyone. Instead of being like pissed off all the time because everyone was always rude to him. Okay, so you can do like math with logic operators. So you can do like 1 and 1, 4. Right? And you figure out what this one equals.
Okay, so we first do the AND operation, and that's gonna be a 1. And then we do an OR operation, and that OR operation will be 1. And then we do 0? I don't understand.
Huh?
I'm confused at the 0.
So you said this equals 1?
Yes.
Okay, so I will rewrite it. Is this what you have in mind?
Yes.
Okay. Why are you confused by the 0?
I don't know what the 0 is.
Well, or takes two things, one on the left and one on the right.
Ah. Okay, then it would be 1.
Yes. We're oring the 1 with the 0, and we get 1.
Hmm.
So can you make a tree of this?
Okay. Tree. Okay, so what is the thing we're doing? Uh, what kind of operation are we doing? I think we're doing a OR operation. Maybe I can just write the symbols you have.
Either way is fine.
Okay, and then the OR has 2 inputs. One of the inputs is an AND operation, and the other input is a 0. And with the AND operation, it has a 1. That's an exclamation mark. 1 and a 1. Okay, so this ends up, no. Edit individual node. Which button can do that? Space. Awesome. Ends up being a 1, and then this ends up being a 1.
Yep, you got it. Okay. Try this one.
Okay, so we have a not 1, which I think is the same as 0.
Uh-huh.
Okay, zoom, zoom. Okay, so what kind of operation are we doing? Okay, I'm not sure how to figure out which operation we're doing. So maybe I look at the thing we do last. Okay, so the first thing we do is like an AND operation, and then we do an OR operation, then we do the middle OR operation. So I think the middle OR operation would be the top of the tree.
Yeah, you can always just drag things around later. Just do just don't use the root node because you can't drag it.
Hmm.
And then if you need to move stuff, it's easy to move later.
Move. Wait, this one I can move maybe.
You
Move.
can't drag it around inside the tree.
What?
Like you could drag this node and you could put it like up there.
Yeah, this one I can't do that.
Yeah,
Okay, so
right.
just tree. Okay, so then I could be like, okay, we're gonna have like an and somewhere, I'm not sure where, and we're gonna have like an or, and we're also gonna have an or. I'm not really sure what they're doing, I'm just putting them in, kinda.
Yeah. You don't have to figure out the whole order at the beginning. You can start making it and putting the chunks together.
Okay, in the math problem, uh, okay, the second one, when you go from like left to right, it seems, I'm not, or okay, it seems like it can be confusing which OR it's using, but I think it's using the OR on the left because that's like the first operation we're doing. And then the second OR will use the OR as an input. The second OR uses the
Yeah,
first OR as input, and the first OR uses the 2 ones next to it.
Yeah, however, it doesn't actually matter because or doesn't care about the ordering.
I don't quite understand that, but I want to do this tree first.
Mm-hmm. Go ahead.
Okay, so we have a tree. Then, like, if I don't know what order to do things, I can just be like, okay, this one's like on the left or something. We have or, and then we have a
You can start
not
with the things that are more obvious.
and a one. Uh, what are the obviousest things? The and is pretty obvious.
Yeah. And for the not, you should give it its own node, not as an operator.
Uh, huh. Okay, so we're putting like, okay, that seems like it makes sense. It's like we have a one in it, and then we put it into the not one,
Yeah.
and then we put it into the not. Huh. Okay. These ones are not distinguished enough from the rest of the things. How does an eye look? Not much better. One it is.
Just change the ors into the word or, I guess.
Okay, and then we have an and. And. Uh, 1, 0. Okay, and then we have an or, which uses both of these as inputs. Okay, I think I made the tree. Now I'm gonna add numbers.
Okay.
What does this or become? 1 has not 1 here, which is the same as 0. And then it has a 1 here, which is 1. If both of these were not 1s, then this would be the 0. This one's okay, so this one's gonna be 1. This one's gonna be 0. And then this one's gonna be 1. Sometimes the stream just like lags way behind for some reason.
Yep, so it's a 1. There is another way to write the tree.
Ooh.
But first I'll show you. Okay, so okay, so these are all the same thing in a different order. Is the answer going to come out the same?
Okay, let's look at the first one. First one is gonna be 1, and then the second or is gonna be 1. Okay, so that's gonna be answer 1. Okay, this one is gonna be 1. The second one, wait, what's happening? Okay, it's 1 and then a 1. Yes, this is gonna be 1. Okay, the third one is gonna be a 1, and then there's gonna be a 1. So that's gonna be 1.
Okay, does it make sense to you that the order doesn't matter?
Hmm. Could it matter if we have even more or if we have even more or operations?
What do you think? Does the order matter? Is there what is this one? And then is there an order where you could get a different answer?
Is this one order? Okay, so we have a 1, and then 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 it's 1, and then that one's gonna be. Okay, the way I was thinking about it is like if we have a bunch of zeros on one side and then the ones on another side.
Okay, well, what's this one?
I think this one's going to be 1. Wait,
Okay, I agree.
I might be able to just look at the very last one and be like, well, the very last operation has a 1 next to it anyway, so it has to be 1.
Alright, what about this one? Do you have
Uh,
any doubts or thoughts about what this might be?
okay, I think I found a semi cheat code, which is I can look at the last OR operation and be like, that has a 1 to the right of it, so it's going to be a 1.
Okay, well, I'll fight with your cheat code right here. What do you think of this one?
Uh, well, the OR on the left gate is always going to be a 1, so remove 2 of the 1s and just have the very left one be there. Okay, so the first AND gate turns into a 1, and then that spills into every other AND gate. So
Or
every
gate.
other AND gate, oh, right, OR gate. First OR is
Okay,
1, so that goes into every other OR gate until the end, so it becomes a 1.
yeah, what about this one?
Uh, this is also a 1 because of cheat code. Wait, so could you have a 1 literally anywhere in a chain of OR gates, and then it will end up being a 1?
Well, what do you think? You tell me.
I think if you have a 1 anywhere in a chain of OR gates, uh, it will end result 1.
What about this one? Go through it manually, step by step.
Okay, so we have the first
What does this
OR
make?
0, and then
Now what are we at?
0.
Now what?
That gate's gonna be a 0.
Now?
That's a 0.
Now?
We have a 1.
Now?
Uh, it's gonna be a 1.
Now?
Still the 1 because we're holding on to the OR
Yep,
gate.
now?
1,
Now?
1.
Okay, do you think the order matters?
No, I'm not sure if there's a way it can matter when you're using multiple gates. I think it could matter if you're using multiple gates somehow, like different types. Uh, but if it's just ORs, then it definitely does not matter.
Okay, I got distracted a little, but I think I heard you say that the order doesn't matter.
If you're only using ORs, it does not matter. If you use multiple gates, then maybe it will somehow matter.
Yes, that is a good answer. Okay, now I'm gonna make a tree and show you how we can do that tree differently. Tree. Here we can do or and. What are the things we're ORing together? We're ORing the not with the 1, and we have a 1, and we have an and 1, 0. We can OR together 3 things instead of having 2 separate OR gates.
It feels like we're doing something like prefix notation versus like infix.
Okay, so this, you can also be like or 0, 0, 0, 0, 0, 1, 0, 0, 0, something like that.
Hmm.
So it's very similar to what we did with plus in the past.
Yeah. Prefix thing. And the infix is
Yeah, alright, now we're gonna look at and. So, oops, wrong one. There we go. Wrong one again. And, and, and. What is this one gonna make?
1.
You got it.
There aren't any zeros to spoil the result.
What about this one?
It's gonna be a 0.
Okay.
I
What
think you could
about...
have 1,000 ones and a single 0, and it will be 0.
I made it half and half. What's this one?
Uh, okay, so what's the first AND? It's going to be 0. And then the second AND, therefore, is going to be 0. The third AND is going to be 0.
And your conclusion?
0.
Okay, what if we do it in the other order, though? There we go.
Okay, so we have 1, and then 0, and then 0. Okay, my belief still stands that we could have infinite-ish ones, and then a single 0, and then it will be 0.
Okay, so what do you think the answer to this one is?
0.
Okay, and does the order matter
Uh,
of the
no.
ones and the zeros?
No.
Okay, good, correct.
Oh, hey, so we could just have a single AND gate.
Yes, we could have and 1100 or something. Okay, what about with not? So, does the order that you do the knots matter?
Mm, I don't think so.
I agree.
uh,
So like we could have like not of one, right? And then what if I copy this knot, right? I'm gonna cut that one out, I'm gonna put it over here, then I'm gonna take this one, I'm gonna move it here. Does that matter?
not.
Okay. Okay, so how do you figure out what the answer is gonna be? Here we have 4 knots. What's this one gonna make?
Okay, I think that's going to be a quadruple negative. What's a double negative? It's 1. What's a quadruple negative? 1.
Okay, so what's not one?
Oh, cool. So you can just see if it's like a even or odd number. And
You got
then,
it.
oh yeah, I remember something about this with like gears. I remember my grandpa said something about he took an IQ test, and like one of the things was like if you have like 10 gears in a row and like the one at the very top is like spinning clockwise, uh like what
Oh,
direction would the
do the
next
gears keep reversing direction?
yeah, so they like keep reversing direction, so you can just like figure out uh what the second one would be, and then like if you know what the second one is, you'd know what the 10th one is, I think. I'm pretty sure that's how you do it. Because then, like,
Okay, so what's not one?
what is 0?
No, not one.
1.
No, no, not one.
Okay, I'm gonna activate cheat code. That is an odd, so it's gonna be the opposite of the answer, so 0.
No, no, not one equals.
That's even, so it's gonna be equal to the input.
Can you get it by looking at the previous one?
Uh, yeah, I guess so. It'll just not be the previous one. Oh,
Yeah,
hey.
here, I'll give you a hint. I'll put parentheses. You may recognize this from right here.
Yeah.
So what's this one?
0.
Yeah, alright. 1, 2, 3,
1.
4, 5, 6.
1. 1. 1. 1.
Okay. Yeah, so not one, or we'll use X. So it could be anything. Equals, not X, equals X. Does this make sense? Every two negatives cancel out.
Like every two negatives cancel out. Yes.
And you can do it with odd ones as well. So you can have 3 equals 1 equals 1, 2, 3, 4, 5. And it's all going to be the same. You can just add or subtract two knots.
Mm-hmm. 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 Okay, so 1 equals not 1.
Yeah.
1 equals a billion not ones. A
Uh-huh.
billion knots and a 1.
Yeah.
Huh. Ew,
But
maybe you
don't
could
lose
do.
count while you're writing out your billion knots, though.
Maybe you could do something like that to make the code look more bloated. Maybe if you have like more bloated code, people will be more impressed because you can say you wrote like a few thousand lines of code when you could have just wrote like 500 or something. And they'll be like, whoa, you wrote 2,000 lines of code. It must be really good. You can write a lot.
Okay,
And then you can
so
just show it.
suppose, yeah, you can bloat your code with a lot of things. Right, suppose I'm going to put 100 knots in front of a 1, right? So it's supposed to be like 100 knots and then a 1, and then they're going to be equal. Make sense
Okay, if
so
you have
far?
100 not ones, that's going to be 1. I
Yeah, okay.
agree with
So I'm writing them out. Oh no, I lost track of how many I wrote.
that.
So I have a number that's near 100. You know, like I tried to do roughly the right amount. What are the chances that this comes out correct?
What are the chances? Uh,
What are the chances
one.
that it's equal anyways?
Uh, I think it's like about 50, but not exactly 50%.
I agree. Something close enough to 50.
Because like if you lose count on the very first keystroke, then it's not 50-50. It's like very much just 0. So I think 0 has a slight advantage.
Huh? No, I don't stop when I lose count. I keep writing them until I get to around the right amount. I'm like, well, I think I did around 50. I'll just do around 50 more.
Huh.
So I'm not going to stop at like 1 or 2.
They're not sure.
So
Uh,
I have a number of knots that is near 100. It could be 101, it could be 102, it could be 103.
yeah, I'm not exactly sure how the chances work with this, but it doesn't seem like it's gonna be exactly 50%.
Yeah, but something pretty close to 50 because I could have
Yeah,
an even number of knots or I could have an odd number of knots. So there.
I think like the higher you go, the closer it gets to 50.
If I'm doing, I have around a billion knots, but I lost count. Yeah, it's be very hard to guess if I ended up at even or odd.
Yeah.
Okay, so the next one is Zor. So 1 Zor, 1 Zor, 1
All right,
equals.
exclusive. Uh, I think this is gonna be a 0.
So what is 1 Zor 1?
Wait a minute. Okay, 1. No, that's gonna be a 0 because it's exclusive, and this isn't.
Yep, it can't be both.
And then the next one is gonna. It has a 0 and a 1, and it has 1, so it's gonna be a 1.
Yeah, so we can substitute the 1 Zor 1 is 0, and then the final answer is, you said 1.
0. 1 or 1 equals 0.
Okay, so
Uh,
now this one.
okay. I'm gonna try to find the cheat code. Okay,
You can
so
just do a couple more manually and then look for a cheat code.
uh, Okay.
It's usually easier that way.
0, then 1, then 0.
Okay.
Okay, so even amount of Zors is 1, odd amount is 0. I think I found the cheat code.
So you think it alternates?
Yeah,
You're correct. Okay, now what about this?
it's gonna be a 1.
Actually, I'm gonna write this in an easier way for me. Or that equals.
1.
Okay. What about this one?
Oh boy. 1.
What about this one?
1.
All right, we'll do
I took
one
a leap
more
of
of these.
faith and I'm sticking to it.
What about this one?
Not 0.
Okay. Now, what if we start mixing them together? So we'll do this.
I think this is gonna be a not. A 0. A 0. 0, 0, 0, 0, 0. If it was a 1, 1, 0, 0, then I think it would be 1. I'm kind of not sure right now with these
Okay, well, let's
multiple
do that.
inputs. Now I feel like it's 0.
What about this?
Wait, what is exclusive OR? Uh, okay, so we do an OR operation. Uh, huh. Can I just like do another XOR? Okay, so let's say the XOR operation for 1100 is 0. Then what if we do an XOR for 0 and 0? That would be 0. Does that work? Can we do something like that? Does that work?
Hold on, I might have screwed some of this up. I'm not very practiced with soars. I need to think about this.
Ah, go back.
Okay, exclusive OR comes out true if one of the inputs is true. If you have a bunch of zeros, you're always going to get 0. But if you've got 1, 1, then you're good. But if you have 2, it's not exclusive. Yeah, so. Alright, sorry, I missed what you were saying, but I think we have all the answers correct.
Wait, so is there a way to have multiple ones and XOR be true?
Uh, well, why don't you look over here?
Hmm. Okay, what if you just have a single XOR gate operation thing? Then could multiple ones be true?
The single is the same thing. It's
Oh,
so I'll write this one out for you. XOR of all those things means, do you know how to write it out?
I don't think so.
You know how to write it out with plus?
I think so.
Okay, write out this one.
Okay. Uh, plus.
Okay, and then write out this one.
Hmm.
Works the same way.
1, Zor 0 Zor 0.
Yeah. What's that? We're just doing Zors with everything.
Huh. Okay, this is 0. And this is a 0, and this is a 0. Look at this here. This is a 0. This is a 1. This is a 1. So 1. Press 1.
Okay. And then what if we have 2 zeros?
Okay, so we can do something like this. 1. Wait.
Alright, what about this one?
Wait, I'm confused. I didn't mean to input 1 when I said 1.
Oh, you weren't done? You're in the middle
Okay,
of something. Okay.
this is going to be a 0, and then this one is supposedly a 1. And this one's going to be a 0. And this one's going to be 0. So this is 0. 1, 1, 1, 0, 0 is 0. What if I put a 1 on the end of it? I'm curious. Okay, so
Wait.
operate. Oh,
Why don't you make a tree of that one?
this thing right here.
Yeah.
Uh,
A tree where you have like all the Zors, don't just be like
okay.
a tree with all as many nodes as possible. Because you could do this. Tab 1, 1, 0. You could just put them all under one thing, but it's not going to help you.
Okay, so 1, 2. Okay, so we have a Zor, and then it has a 1, 1. And then we have another Zor. I'm gonna figure out how to attach them later. Wait, I think they're kind of dependent on being attached immediately. Okay, so this one's like the parent, I think. Like we do this one, then like we do this first Zor, then we do the second Zor, then the third, then the fourth. So this is like parent kinda.
Hold on a
Also,
second. Do you usually do the things at the top of the tree or the bottom of the tree first?
bottom.
So you want to do this one first, right? That's what you're saying?
Yes,
So should it be near the top or the bottom?
bottom.
So it should be a parent or a child.
Child.
So
Okay,
you're
so
going to do it, and then it's going to be the input to something else, right? So is that a parent or a child relationship
can we
when it's
do
an
it
input to something?
in child?
Yeah.
Huh.
So you're going to
Can we
take
do it?
this, and you're going to XOR the output of this with something else. What do you XOR that output with?
Okay. What do I XOR this with? I XOR this. Okay, so you are you. So these are the same. And then you, 1 goes into 2. And then you would be the child of like XOR 2. XOR 2. You can have like the
Sure.
like 1. Okay. And then what's XOR 2 working with? He's working with XOR 1 and 1. Okay. Then we have XOR 3. He's working with XOR 2 and 0. Okay. Then we have XOR 4. Oh. He's working with 3 and 0. Okay, so this is going to be 0. Okay, this is going to be a 1. Again, this is going to be a 1. And this is going to be a 1. Okay, I think we could have as many more XORs as we wanted, as long as the other input for every single XOR after this was 0, and we kept this same XOR input, then it will be 1. As long as the second input is 0 and the first one is 1, it will always be 1. So we could go up to like XOR 72, and as long as it's like additional input is 0, it will be 1.
Yeah, okay, so look at this. 1 XOR 0 equals, what's this?
1.
Now what's 0 XOR 0?
0.
Okay, so did it change? Is this what you're getting at, right? You can XOR with 0 and it doesn't change the 1?
Okay, we can XOR with 0 and it doesn't change the 1. Yeah.
Okay, but then in this one, did it change?
We XOR 0 and it changes.
Does it change?
Does it?
Does the first thing get changed?
No.
Right. So if you XOR with a million zeros, what's going to happen? Like, what is X XOR 0?
X.
Okay, and then what if we have XOR X 0 0 0 0 0 0 0 equals?
X.
You got it. Yeah. You can just
And
have as
then,
many zeros as you want. They never change anything.
no, wait. If we do XOR X1, it will be not X.
You are correct. XOR X1 equals not X. Okay, and then if we have XOR, like 1 1 1, what is this?
Okay. I feel like it's gonna be a change. Okay, so it's gonna flip. So 1.
Okay. Now, what about this one? 0 0 0 0 0, oops, 0 0 0 0 0 0 0.
Okay, so every 1 changes it. So first 2, no change. Next 2, change. So like first 2, 0. The next 2 are 1. Then the next 2 are wait. I think I was
Do you see the connection between these two problems?
connection between these two. Oh, there's 3 1s.
Yeah.
And then the zeros don't matter because they don't
Yep.
change anything.
The zeros don't matter.
So
That's the
1.
trick. Okay. What if the zeros are in a different order? I'm gonna take these, put them here, take these two, put them here. What's this?
I'm feeling like the I'm not sure. I'm gonna go with an 1.
Yeah, the zeros don't matter, so no
What
matter
if
where
we
they
have
are, you just ignore them.
2 1s at the very beginning?
Okay. 4
Uh
1 1 0 0 1. What's that?
Okay, so the 1's become a 0, and then the 1 and 0 become a 1, and then the 1 and 0 become a 1, and then the 1 and 1 become 0. I think it's 0.
I think you got lost.
Huh.
How
Okay.
many ones do
How?
we have?
3.
Is it the same as these?
It's the same amount of 1s as those.
Then why would the answer change?
Because they work on each other immediately, and then they turn into a 0.
Do they work on each other eventually in the other problems?
Hmm. Okay.
Like if I add an extra 0 in the middle, what happens at the beginning?
Okay. It
You do
becomes a
these two, what
1,
do you got? And then you do this, what do you got now?
a 0.
Yeah, so the 1 and the 1 ran into each other after you got through the 0 in the middle. Does that make sense?
Yeah, they work on each other eventually anyway. Huh. Okay, so then doesn't matter when they work on each other, they're going to work on each other eventually. They could do it like at the very end, or at the very beginning, or somewhere
Yeah.
in the middle.
So it's always a lot like this one, where we just delete all the stupid zeros.
Huh. Okay, so I think it's gonna be a 1.
And this one?
1. 1.
Okay, so what if we have a Zor and we have 17 ones?
Bizarre.
You know what that's
17.
going to be?
What's an odd number of 1s? 1. Okay. And
Yeah, what
17
if
is an
there are
odd
20
number.
ones?
0.
You got it. So you can take every two ones and they cancel each other out and delete them. Does that make sense?
Yes.
Every two ones is going to make a 0. So it's just, do you have an odd number of ones? That's the only thing Zor asked.
Hmm.
Count up all the inputs and is there an odd number of ones?
Okay. Odd. 1, 2. Yes. Odd means 1, so 1. Yes, if you have 20
So
billion
I
and
give
one one,
you
this is going to be 1.
this. What's this one?
0.
You got it.
1.
You
0.
got it.
1.
I think there might have been an audio delay issue.
Yeah.
You're saying
Yeah,
numbers as I typed or something. Or a video delay.
yeah.
Okay, so does the order matter?
No.
Correct.
Huh. It does not matter.
But it does matter with implies.
Okay. Order matches with implies. Yeah, I think so. You have like the. Wait, so what's implies? You have like 2 inputs, and then it makes an output out the top or something.
Yes, implies also has two inputs to one output. It's always saying if the first one, then the second one. That's the claim. And makes the claim both of these are true. Implies makes the claim if the first one is true, the second one will be true.
Okay. I think I understand. First
Or
one's true.
makes the claim at least one of these is true. XOR makes the claim an odd number of these are true.
Okay, so XOR is at least one of these is true. And
Or
or at least one. So you could have one 80,000 zeros, and it will be 1. Okay, and then not or is okay, what's not or? How does that work? Okay, 1 exactly is true. Okay, so wait, there's not or and there's exclusive or. Not very true. Wait, your and says both are true, but the NAND says not all are true. I feel like the and could have all are true.
I might never pay attention. Let's see. Okay, yeah, so at least one is false.
Yeah. Yeah. Yeah.
If at least one is false, then the and is going to come out false, and then when we not it, we'll get true. And if none are true, then our or will come out false, and when we not it, we'll get true.
Yeah. Okay, so you can make a AND gate with an AND by putting it into a NOT again. So a double NOT NAND will make a AND. And if you need a NAND gate, but you only have a NAND, if you need a NAND gate, but you only have an AND and a NOT gate,
Are you
you could
saying
hook
that
the.
if you do NAND of NAND, are you talking about chaining NANDs or something?
No, I was saying you could put a NOT on an AND.
Oh,
So double NOT AND.
okay.
So if you're in need of an AND gate, but you only have a NOT AND and a NOT gate, then you could hook those together and you'll
Oh,
get
you're
an
you're
AND
saying so
gate.
not of NAND of XY equals and XY? Is that what you're saying?
I think so. If you do a NOT NOT, then it becomes the original thing.
You are correct. So NAND XY equals not of and of Y. So, you know how substitution works?
No.
Okay, so we know that NAND XY equals this thing, right? That's what this
Uh,
tells us? This
I'm kind of
equals this.
confused by how it's written. It seems like a mathy thing, which I might not understand. Maybe the
Okay,
X and
so
Y
the
are
equals
confusing.
sign means whatever's on the left equals whatever's on the right.
Okay, so NAND is the same as a NOT gate and then also an AND gate.
Yeah.
So NOT gate plus AND gate equals NAND gate.
Mm-hmm.
That is true. I don't know what the X and Y are though.
They're ones or zeros, but we don't know which one. Mystery number.
Okay. So,
They're called variables.
okay. There you go.
So it works no matter what the x is and no matter what the y is. Like the x could be a 1 or a 0, the y could be a 1 or a 0, and it's going to come out true no matter what combination you use.
Mm.
Make sense?
Not sure. It's going to be true no matter what combination we use?
Yeah, so you can try it out. So here, try writing it out. Put this in Discord.
Okay.
Tutoring. Yeah, okay, copy paste that 4 times. Okay, now we'll go through in the first one and replace both the x and the y with 1.
Okay.
And what if x is 1 and y is 1? And then you can do it on the other side as well. The x and the y on both sides have to be the same thing. Like there's only one x.
And the y have to be the same thing.
Okay.
Uh,
X is a particular number.
x
So
is
if you see x multiple times, it has to be the same number every time.
okay, so particular number. Okay, so if x was 0 here, then it would also have to be 0 here.
Yeah.
And then if y is like 1, then it also has to be 1 over here.
Yeah. And then you can do the other 2 combinations of possible values they could have.
I feel like there's a standard way to write this, which I did not write in the standard way.
This is fine. Okay, so now you can check, is each of these correct? You can check all 4 times, does it come out right?
Okay, so
on this one, you would start here. What is and of 1 and 1?
What is and 1, 1? It would be 1.
And then you have not of 1. What's that?
0.
0. And then you look on the other side. What is NAND of 1 and 1?
0.
So it came out correct, right? They turned out they were the same.
Yes.
And then you can go through and do that with the other 3 and see if they always come out the same.
Okay. And okay, so this one, 0 is gonna be 0, not it's gonna be 1. So then NAND. What's NAND again? Not NAND. It's like at least 1 is true. Or wait, at least 1 is false. One of them is false, and then it is true. Okay, one of these is false, and then it would be true. So this would be true, and this would be true. It's like 1, 1 here. Because that's going to be a false and a true. And that's going to be true. So like at least 1 is false. Okay. It's going to be false and true. Then this is going to be true. Yeah.
Okay, so they always come out the same. So
Yeah. So no matter
this
what.
thing is the same as this thing.
Yes.
Which means, so here was your claim. Your idea was that not of NAND of xy is going to be the same as and of xy.
Okay. Not NAND is going to be the same as and. Yes. That's my
Right.
claim. And I
So
agree
you could
with
go
that.
through and you could put in the 1s and 0s and you can test it, but I was going to try to show you something, which is substitution. So we know that the 2 red underline things are the same. So down here, we have the same thing. Look, it matches, right? This matches this.
NAND X, NAND XY. Wait. Okay, so the 2 highlighted things are the same. Yes.
Okay, that means, so these 2 are the same, and these 2 are the same, right?
Okay, NAND and not NAND are the same. Yeah, yeah. So NAND is the
So
same.
you think these ones are the same?
Yes.
So what I can do, I can copy this, and I can highlight this, and then I can hit paste and swap it
Yeah.
because they're the same.
Yeah. The same,
Make
so you can
sense?
just swap them. Yeah.
And that's
Same
what
thing.
equals means. Equals means they're the same.
Yeah.
Okay, so now
Okay.
I have this. You can look at this, and maybe you'll be able to see whether it's true or not.
Okay, so not in y equals and uh
You know what not x is?
mm, 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 x.
Uh-huh.
So not and would be NAND. Not and would be and, I think.
Yeah, or just you have two knots. Two knots cancel each other out. So
Okay.
whatever you put in the middle, it's going to come out the same.
So if we had a billion knots, that would be an even number, which would cancel themselves out. So it'd be as if there was no knot.
Yeah. So you are correct with your idea that not of and is a way to get an and. Or, no, that's not what you said. Not of NAND is a way to get an and. This one. That's what you said. So yeah, that's correct.
Okay. If you're in need of a not, of like a not and or a not or, uh, you can make one by just putting a not gate in front of an uh, or an and gate. If you don't have like a dedicated NAND or a dedicated OR, you can just make one by putting a not in front of one of the normal ones.
Okay, so there's something pretty cool. Let's give it a shot.
Okay.
You can use NANDs
hmm
plus x plus ones and zeros. These are the things you're allowed to use. Can use. Your goal is to make not of x. Goal.
Okay.
Create. How can you make not of x out of NAND, x, 1, and 0?
Okay. NANDs. So I can have as many NANDs, as many X's, as many ones, and as many zeros as I want.
Yes.
Okay. So what is a NAND gate? How do I
So you
turn?
want to say not x equals, and then you're going to write the other side using these things. So it's how do we build a NOT gate out of NAND gates?
How do we build?
And we get NAND gates, and we get a wire with the input. We get the same input, you know. And the X is the input wire, and then the 1 is just a wire that has current, and the zeros are a dead wire. So you can have some, you can put in some dead wires or some wires with current if you want to.
Okay. So what is a NOT gate? Okay, so not gate just like swaps from a 0 to a 1. And what is a NAND gate? A NAND gate is not and. So oh wait, wasn't there something we did with the NAND? Okay, so if we have wait, so what did we do? We did something with exclusive ORs. It's like if you have a 1, it becomes okay, so I feel like there might be something if we have like, okay, with XOR, XOR.
Yeah, we did it
Yeah,
with XOR earlier. It was right here. This is what you said, I think.
yeah. All right. I wasn't realizing we did it with the X as well. Uh, I was just thinking like,
Yeah, I'll copy this down here for an example.
mhm.
And I'll put it in the other format. I'll put the not on the left. So if your goal was to use XOR x, 1, and 0, then you would have a solution.
XOR. So what's that?
If your goal was to
Not
create a NOT gate out of XOR x, 1, 0, then this would do it. Make sense?
If I wanted to make a NOT gate out of XOR x0, okay, so not x is the same as having the XOR x1. Okay, so x could be a 0 or a 1. Okay, I'm
There we go.
getting slightly confused by all the writings.
Okay, look at this one.
Okay,
We're
this
doing the
one.
problem with XOR first. Easier.
Okay, so can use okay, so go create not x. Okay, so we can have XOR and x, a 1, a 0. Okay, so what happens if we just have a XOR 1, 1? What does not OR do? Okay, what does OR do? Okay, this would be 1, and then the not OR is gonna bring this to a 0.
XOR
Okay,
1, 1 is 0. Right. So write out the whole thing, and then you can check them like we were checking earlier.
write out the whole thing.
The
Uh,
highlighted thing? Take the highlighted thing,
okay,
and then
take
put in
that.
different values for x and see if it comes out correct.
Okay,
I'll throw them.
okay. So I'm gonna take this thing and
Make 2 copies of it, because x
okay,
could be 1 or 0.
you want it. Okay, so like we could do like 1 and then we could do like 0.
Huh.
Okay,
You can
so
figure out what you have on the left and figure out what you have on the right and see if it always works out.
okay, so this is a not 1, so this would equal 0.
Uh-huh.
Like this would be 0 and XOR 1 1 is gonna be 0.
Uh-huh.
Okay, so like OR would say this is 1, then we not that, so it's gonna be 0.
XOR is not or.
Wait, is
The
not
X
not.
doesn't mean not.
Oh wait, it's
It's
exclusive OR.
exclusive or.
Right, so it has to be specifically 1. Right. There's NOR, but this is an XOR, not a NOR. Okay. XOR. Okay. Okay. Equals 0. Okay, so not 0 is 1, so this would be 1. And then exclusive OR is like an odd number, so this is 1.
Yeah.
Okay,
When
so
we're
these are
dealing
both.
with only 2 inputs, then XOR is just exactly one of them is true.
Yeah.
One or the other is true, but not both and not neither.
Okay. Now we need to make a NOT gate with XOR. So like we want, say, let's say we have 0 and we want to make the 0 go into a 1. So we want like to put a 0 into the XOR and then it comes out as a 1.
Hmm.
So that's like one thing I can try. Uh, yeah. Okay, so I want to put a 0 and a 1 and I want it to come out as a 1. Uh, okay, this should come out as a 1. Awesome. Okay, what if I put in... Okay, so this seems to be working as a NOT gate for 0. As long as I
Mm-hmm.
have a 1 in it, as long as I always have a 1 in it, it will flip the 0. Now, what if I wanted to do it for a 1? I have a 1, and then... Okay, so this is just like the one I'm putting in, and this is the one that always stays inside this. Like, I plan on
Yeah.
having this one with every XOR gate I have, because it will flip this other one. Let's see if that works out. Okay, this will become, okay, uh, it's not exclusive. This is going to be 0. So like, this became 0. This one is just supposed to be here, like with every XOR to flip the other one. Uh,
Yeah. So
like,
we create a not gate by having one input for the NOT and having a one wire attached to the second input, and then it works like a NOT gate.
Yeah, so we just have an always active wire attached to it, like just constantly active, constantly putting power into it, and it has no way to stop. It just always is putting power into it. And then we have another one which can either be 1 or 0, and then it will flip. Like if it's
Yeah.
a 1, it will flip into a 0, and if it's a 0, it will flip into a 1. Okay. How can you maybe draw something? What does this annotate button do? Okay, I can draw. Cool.
Oh, is
Okay.
that zoom drawing?
Yeah. Okay. So you can have like uh
Okay. I
oh
drew on
cool. You
your
can,
screen.
oh my god, I can see it on my screen as well.
Yeah. Yeah, that's something Zoom has.
Whoa. Okay, so let's see. We can have an X. Oh, you're ruining my tree.
I tried to color in the lines.
Okay.
Tried to color in the tree, but I didn't do very well.
Uh, okay, I'm bad at handwriting. I need to figure out how to do this R. I'm just gonna copy that R. Uh, good enough. Okay, XOR. And then it's like in a box. This XOR is in a box, and it does an operation thing. And then it's like connected into a 1. So this is like always a 1 output. So we have an XOR box here, and he's connected to a 1, and he's always a 1. He never changes from a 1. He's like a 1 box.
Oh, when you hit clear, it gives you a menu. Clear all drawings or clear my drawings.
Don't clear my drawings. No. Okay.
My drawing.
Yeah, so we have a XOR gate, and then it outputs, right now, it's unknown. How do you draw a question mark? Okay, that's what the question mark looks like. Okay, it did a question mark. Right now we don't know what it will output because we don't have a second output. So if we hooked it up to a 1, I guess we can have like a mystery box here as well. Like we don't know what the output will be, but whatever it is, it gets flipped. So is there an eraser button? Annotate. Uh, move. Hmm, eraser.
I
Uh,
updated your drawing on my screen.
hmm, that does seem like an update. Uh, oh, I can use different colors. Can I?
I think
Okay,
so.
draw. Okay, there we go. Different colors. Okay, and then it hooks up to this, and then you had the. Okay, so this is just like a constant wire. It's always going to be 1. Then it hooks up to a mystery thing. It could be anything. Who knows? And then it outputs uh, the opposite of mystery, or the opposite of X, I guess. It could be anything. Who knows what it could be? Okay, so how do I do this? Eraser. Okay, and then I get rid of the question mark, and the question mark can turn into an X, which could be a variable number. It could either be 1 or 0. And
Yeah.
then
You can
this
name your
will output
variables anything, including question
not
mark,
X.
or triangle, or square, or something. X is just a common one. One letter variables are common.
Okay, it could be mesh.
But you could name it input, right? That would be like a clearer. A
Huh.
clearer thing to name it would be input wire or something.
Too much letters. Oh, hey, text. Huh.
Close
Select.
enough.
Boom.
Okay, you moved it.
Okay. And then you can have like not. Okay. And then select.
Yeah.
And this box will be the not input. So
Okay, so I'll name it input here. Yeah. Easier input.
mhm. Okay, so yeah, we did it with the not OR gate. You have a constant one wire hooked into it, and then is there a way to select this entire area? Move. It seems kind of hard to read over here.
Good enough.
Okay, now let's make a new gate. Yeah, I want to figure out how to do this with a not and. So let's try to use a not
Yeah,
and.
so this time you've lost your XOR tool. You're not allowed to use it anymore, but you can use NAND.
Okay, so the way I could do it with the XOR if I wanted to, or if I was allowed to, would be I have the XOR and then I hook up a 1 on it and it's always 1 and the 1 is constantly 1 and then uh, it will flip whatever the other input is.
Yeah.
Mhm. Okay, now what's a NAND gate? It's not AND, so let's try to make let's do something with a NAND. Okay, have a 1 and 1. That's gonna be a, okay, the AND says yes, so not AND would say no. Okay, if I'm having problem figuring out what the NAND would say, I can just think, what would the normal version say, and then add the opposite of that.
Yep, that's one way to do it. Another way is at least one is false.
Okay, at least one. So if there's like one or more, it's false.
See, any zeros, you're gonna get false.
Oh no, insert. 0. So this is going to be, well, and says false, but not and says true.
Uh-huh.
Okay. And with normal and, it's just any 0 is false. Okay, so not and is true if there is not both true. Okay. The only time not and is false is when there are 2 ones. If there are 2
Uh-huh.
ones, then not and is 0. Okay. Yeah. Okay. What if I just tried to do the exact same thing with the OR gate? So we're just gonna have a constant 1 hooked into it, and then uh, the 0 will be, and then it has like a variable. So like, let's see. If we have a NAND and it has a 1 and a 1, then the output will be 0. Okay, so managed to flip this one.
Yep,
Okay,
working so far. You're halfway there.
I don't think that's how it works. Okay, so we have a 1 and a 0. Uh, wait, okay, so we have a constant 1. This is always a 1. It will never not be a 1. It's always 1. This is always 1, and so is this.
Hmm.
Okay, and then we add a 0. What does the AND say? AND says false. What does the NAND say? Not AND says true. Okay, so this seems like it should work. So this is just like kind of one unit, and then we have like the variable, like the input.
So NAND, and what should I write as the inputs to NAND?
X.
X? Okay. I
Wait,
called it input this time,
wait a
but
minute.
X also works. And then what's the other input to NAND?
Wait, I'm kind of confused. Okay, there's a constant input, which is the 1, and then there's the variable, which you can put in whatever you want. Uh,
Yeah, which I named input. I don't know if that's more or less confusing than X.
okay.
Should I name it X again?
I don't know. Okay. The variable is going to be x. So if
Okay, we'll go
whatever
with
we want
X.
to put it is x. And then the constant is just 1.
Okay, is this what you want? NAND, you put in X and you put in 1, you get out not X?
Yes. You get the opposite of x. Okay. I'm going to make this gate now. Draw. Okay. Now we have future tools, which very futuristic tools, which can do very, very future. This is a box. Then this is a text. It'll be think. And it will be big or not. How do I make the text bigger? I don't know if I can. Okay, this is the NAND box. Okay, and then we have a constant. What? A constant of 1. Okay, so this is constant 1. It's always 1. And then draw. It hooks up to the circle box, the X box. Wait, circles aren't boxes. Oh, okay. And this is X. Okay, and then the output is not X. Draw. Draw. Uh, okay, I drew the gate.
Uh-huh. You got it.
Okay. Oh no.
So it is also possible to make an AND gate from a NAND gate.
Just
Using NAND gates, you can get AND.
using only NANDs.
Yeah.
Okay.
I don't know how hard this one is, but you could try it if you want to.
I think I remember thinking about this because I think like a week ago I was like, hey, can't I just replace every AND gate with an AND gate if I just like do an amount of the NAND gates?
There is a way to do that.
Wait,
Then, another
what if
thing
you
you
have
can do.
an empty? I think it was something with like an empty NAND gate that just like doesn't have any inputs and they're like 0 because there aren't any inputs. and then like a normal NAND gate. Then
I'm not sure what you're saying about no inputs. A NAND needs to have two inputs. At least the type we're using two input NAND gates.
yeah, I mean, yeah, I guess inputs would be 0. By no inputs, I
Okay.
mean like kind of a dead wire. Like there
Well,
isn't a
if you
wire.
put in
It's just
two zeros, you can
yes.
get out a 0.
Yeah. What would the 0 do though?
Not
I'm not sure.
much.
Okay.
So on a related note, if you have and not, you can make or.
And
If you
not.
have or and not, you can make and. So, and if you have NAND, you can use it to make and not, which means you can make or.
If you have NAND, you can use it to make and not. And if you can make and not, then you can make or.
Yeah, and there's also a way to make XOR and all the other ones, but
Okay.
those are less commonly worried about.
Huh. So maybe if you make like,
These two are particularly well known, and the ones with NAND.
okay, so maybe if you make like 5 of every gate using NANDs, then you can like have a universal computer.
Mm-hmm.
Okay, so this is the XOR. I'll put you over here. This is a NAND. Can I copy and paste? Oh.
Yeah, so next time, you might want to learn how to use a drawing program like Paint or Affinity Designer.
Okay, so now what are we doing? We're making a
Oh,
NOT
this
gate
one.
with NAND.
Yeah,
Use
an
AND,
AND gate with NAND. This time AND. You did not.
AND gate. We're making an AND with not AND. Okay, so can we make a NOT gate with NAND? If so, then we could hook on the NOT gate to the output of NAND, and then it becomes an AND gate. Yeah.
Good job, yes. That's a
So we
good way
need
to think about it.
to make the output go opposite. Okay. Come on, there has to be a way to copy paste you. Ah. Okay, I'm just gonna make a new one then. Okay, you go over here. Okay. Uh,
Just use that one if you want to use that right over it.
uh, uh, I guess it could work. What should I do first? Look at the NAND gates more in the tree, I think. I mean, in the thing here. Okay, so if I have, uh, wait, didn't we make a NOT gate with NANDs?
Was that the previous thing we did? Is that the thing you have right here?
Okay. NAND goal create a NOT gate. Uh, uh, huh. Uh, okay. So then, if we say, if we put a NAND gate over here,
Yep, you need another one.
uh, okay, there's a NAND gate over here, and then we have two variable inputs, whatever. Yeah. Okay, two variable inputs.
It's better if you name them different things, although it doesn't particularly matter this time. Like, you can name them
Like Y,
X,
Z.
Y, Z,
I think I'll do like
and
Y
this
and
one
Z
would be a
maybe.
Z.
This one's already X, so I'll just do Y and Z. Eraser. Text. Y. Z. Okay, and then the output goes into here and becomes X. And then the NAND gate turns it into a not X.
Uh-huh.
Uh, huh.
Can
It's
you
kind
write
of
it
fun.
as an X expression, similar to this one? You
I
write it
think
out in
it,
text.
I feel like it basically turns itself into a tree. I think this is a tree. Uh, that's
Yeah,
useful.
you could make a tree of it as well.
Okay. Uh, okay, so we have.
You make your root be like named tree or something,
Okay.
so you can move things around.
Uh, okay. Mm, okay, then I can move this. Oh no. Okay. Move that on top of that. Oh no, I lost the text. Uh,
Let's see. Yeah, I don't know. Learn a different Droid program for next time.
okay. Uh, I'm just gonna have whatever. You can stay there. Okay. S expression time. So I think we can just do like X. And then it has the child of NAND, which has the child 1. Then also has the child X, which has the child NAND, which has the child. Wait. Okay. I think I'm lost.
Uh-huh.
Okay. So not X, and then
Yeah,
NAND
you
is
should have an
child
equals node in your tree.
equal in the tree.
Yeah, so remember this one?
Uh,
Why don't you make a tree of this one that I'm highlighting?
okay. Not X equals NAND X1. Okay, I'll try to make a tree of that one. Okay, so not. Uh, Not sure how to tree that with the equals. What if I just tree not X? I think that would be like not, and then. Wait, I'm doing an S expression. And then we have X. Wait. This isn't really a child though. We're in a tree, so whatever.
There you go, that's not X in a proper S expression.
Mhm. Yeah, use the parentheses like outside of an S expression to show which one to do first. But inside of an S expression, it like shows that itself.
The thing you're trying to do is you're saying two things are equal. On the left, we have not X, and on the right, we have NAND of X and 1. Does this make sense for the tree? There's two different things, and we're saying these two things are both equal.
Okay, so not x is the same as NAND x and 1.
We're trying to make one out of the other, so we're saying two things are the same.
What out of the...
We could write like is the same as. Yeah.
Tree. Okay, so wait, so how would that look like on this? Would it be like the not x, like we have a not x over here, and it's like not x equals like NAND 1x. 1x.
Yeah, you could have like a regular, you have another one over here, like a not wire going into it, and we have a wire coming out of it, and then you take these two wires and you say equals, and then out of it comes a 1 every time we get a 1 out. Equals meaning compare them and see if they're the same. So you could have your thing and this other thing over here, and then we put them into our comparison box, and then a 1 comes out. Because they're always going to be the same.
Okay, it's like, do they equal yes or no? And then it's like, yes. It's like we have an x here, and then it is knotted, so it's the opposite of x. It's like this is 1, then it becomes 0. And we could have like 1 over here, then we put in a knot, it becomes 0. And it goes into here, and it like answers whether it equals not. Yeah. Okay, so what am I doing right now? Am I making a tree of something?
So I showed you this tree. So try to make a tree for making a and out of NAND instead of a not out of NAND.
Okay, we're making an and with NAND instead of a
Yeah,
not.
which is
Yeah.
what you just diagrammed here. So make a tree for this thing.
Okay, so this is how we make an and using NAND gates. But now I need to make this into a tree. I feel like the way I could make it into a tree is just like copy these layers, which is what I tried to do here.
Well, let's take a look. Here. Okay, so we have this. Or specifically, we could look at this part.
I'm changing
And we
my
could
tree.
compare it to this.
I changed my tree a bit. We have an equals box now.
Okay, so equals, not x. You can put the x in as a child because it's an input.
The X.
Not a big
Oh,
deal,
right.
but
Right.
on
This
the
is a
other
not.
side you have NAND, and into the NAND we're putting 1 in x, and the x is going to be the NAND. Yeah, so this x box is not necessary.
Xbox. All right, because the
Wait,
NAND equals.
also your tree is confused.
Oh,
Oh, here you go. Yeah, now you've got a tree. Right, so now you've got one for not and NAND.
wait.
And
I
now
was
do one
gonna
with
put this.
and.
Wait, I'm
Do a tree
confused.
with and in it.
And tree. Okay, I
Right now you're
think.
saying this is how we make not with NAND. Now how do you make and with NAND?
How do we make and with noted? Okay, so this is an
This whole
and.
thing is supposed to be and. Right? That was our goal?
Yeah.
So
Okay.
you've got your NAND stuff. What should we have on the other side?
I think it will just equal. Uh, Wait, what should I have on the other side? Okay. What is the same as this? The Okay, having an and with with y and z would be the same as having this.
Yeah,
Okay, this
there
is
you
the
go.
same as
And do you know how to write this part as an S expression?
let's see. NAND is the parent, then has a child of 1, and then it also has a child NAND, and who has a child of y and z.
Uh-huh.
Okay.
So and of x and y equals NAND of 1 and of x and y. There you go, same thing. It's the of x instead of z.
Okay, so and with x, y variables is the same as a NAND with 1 and then a NAND of x, y variables.
Uh-huh.
Okay, so we can
And you
have
can test this if you want to.
mm,
Like you can make 4 copies of that, and then you could put in the ones and the zeros, and then you could calculate it every time and see if it comes out right.
okay, so this is the same thing you just wrote, so I just need to have like uh, over here we will have an and then it has y, z,
Yeah. And put it equals
and
between them,
these are both the same thing.
and then make 4 extra copies of it.
Mm, Okay,
Right, and then
so
you can go through and you can put in ones and zeros instead of y's and z's and see if it always works.
okay. Ah. Doop, 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 doop. Okay, so this is going to be f. This is f. Okay, this is f, and this is f. Wait, true. Okay, it's not and. This is an and. This is an and. That's an and.
Yep, looks good.
Okay, and so these should have the exact same answer as this.
Yes.
Okay, I'm gonna, for this one, just put the answer right here, or whatever it is. Yeah. Okay, so first we have a not and. So, is this an and? Yeah, that's true. This is an and. Okay, so that's gonna be not and. So it's 0. Okay, then let's put the 0 in here. So we have a 1 and a 0. Okay, is the 1 and the 0 an and? No. Okay, but we have a not and. So yeah.
Yep, and you could try doing it this way, it's a little bit faster. Figure out NAND.
At
At
least
least
one.
one is false.
Okay, so at least one is. Nope. Okay. At least one's false. That's false. So this is false. Okay. At least one's false. Ooh, this one's false. Okay. At least one is false. Yeah. Now they're both true. So then, well, at least one is false. Okay. At least one is false. Yeah. So this is true. Okay. At least one is false. No, they're both true. Okay. At least one is false. Yeah, that's true. Okay. At least one is false. No, they're both true. Oh, hey, it's the same.
Yep, it worked.
Okay.
Okay, so there's two more, or I guess there's three more you can try to figure out. Um, so we can stop here, but then you could try to figure these out whenever you feel like it, sometime later. Okay?
Okay, so the next ones I use ands plus nots to make an or, then use ors and nots to make an and.
Yeah, so use and not to make use or and not to make and use whatever you want of these to make XOR.
Okay.
You can even have NOR.
I can have a nor as well.
I mean, NOR is easy to make if you have or and not, and NAND is easy to make if you have and not. So like these two don't really matter if they're on the list
Huh.
very much.
Wait, so I have a not or
If you
and I
have
have a
and
not.
or not, it's easy to get these ones.
Oh hey, you could have a not gate on the end not. Not.
A not gate,
Yeah.
so just a wire.
No, it goes through two gates.
Yeah, but I mean it's equivalent to a wire.
Uh no, it uses more electricity.
Oh,
Maybe.
okay. Yeah, it's a wire that leaks electricity. Got it.
Yeah. So instead of having the output of one, it has the output of one and like a thousandth of a watt of electricity or something in heat.
Okay, yeah, I put those on tutoring so you can grab those. So you can try
Okay.
doing those three yourself.
Okay.
The first two are very well known and important. And the Zor one is just a thing you can try. I don't even remember if I've done that before. I probably have.
Hmm. Okay, so these ones are like very well known, famous, important. Like a lot of people know how to do them.
Yes.
Uh, okay, and not. Okay, so what is an OR gate? It needs one or both to be true.
So I'm gonna go now. Okay? Or
Okay.
any last questions?
Mm, would it be possible for you to name the stream logic gates? Like have that as a title, because that's the only thing we did.
Okay. Um Logic, gate, tutoring, internet.
I was thinking of having like logic gates at the end of the name, but
I put it
I
at the
don't
beginning.
have this. Okay.
How's this?
Oh,
Save.
definitely. Yeah. Oh no, there's an end stream button. Are you gonna press it?
Later.
Oh no.